All right. So Herman, maybe you'd like to do a quick intro first, and about
Okay,
why
so
we're
I
gathering.
mean, so the the purpose of this meeting is basically to figure out, how could we collaborate further. So Shunyun and I mean, I've known Shunyun since 2012, 2010, something like that. When I first met him in China. It was in China, yeah. It was at the MMV in China. That's right, yeah. Chinwan Dao.
I think
Um,
we met a few times, and also later in Las Vegas or somewhere like.
that's right, yeah, 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 in Las Vegas as well, yeah. And you were just then working on immunology, I believe, yeah, and vast
Yeah.
and vast.io, yeah. So we've known each other for a couple of years. Shunun was appointed as a extraordinary professor since 3 years ago, I think,
Well,
at
almost
Stellenbosch.
2 years. Actually, almost two
Almost
years.
3 years. That's right, yeah. And then we've been collaborating. We supervised a couple of students together, Miguel Smith and now what's his name, Victory.
Victory. Yeah,
and,
Victory.
and I mean, essentially, where we want to end up with is, as in Snow Crash, the metaverse. Where and I read on the
Yeah.
news.
Unlike Elon Musk, who will die on Mars, we might die in the metaverse in the future, or we will meet there somewhere when we old, when we're aged.
So I actually read this morning on one of the news websites that the article was basically about whether the pandemic isn't helping virtual offices become more mainstream. So I think the past year has shown us that the things that we thought was impossible or not necessary, um, maybe more necessary than we think or more possible than we think. So anyway, so after the
Definitely.
mastermind of last Friday, so Gertjan and I, we've been collaborating for, I think we studied together and founded the Media Lab together, and then he went off for a stint in industry, um, running the media distribution company, and he rejoined the university about in July,
First of
June, July,
July.
yeah, and he's been appointed as the chair in IoT. He's been talking about some of the people at agriculture about IoT and agriculture. And I told him about he's seen my Raspberry Pis in my office. And so he's kind of aware of some of the work I've been doing with Minecraft. But I also told him about the spatial routing and the spatial PubSub. And yeah, I think there are collaboration opportunities here, and getting a bigger team together that can actually build something, I think, which could make a difference, in the industry and in the agricultural, hopefully.
That's excellent. Okay, thanks so much for the intro. All right. So so GJ, I think Herman knows best with both of us. So I need to learn more about you. Okay. So I'm thinking about maybe we can start the session with I'll be asking some questions. Okay. And I'd like maybe to learn more about what you have been doing and what your current the goals and some of the maybe challenges you're facing, and then maybe I think I can share some feedback. Okay.
Yeah.
As to a little bit about also what I've done in the past, and also what might be relevant. Okay, potentially for a joint collaboration. Okay, that we can all work together towards something. Because I think the premise of this call is that if we can actually find a topic, that is of interest to all the three of us, and that meets our respective expertise and yes, market potential, whether in terms of funding or in terms of technology transfer or even startups in the future, then I think it would, make a lot of sense for us to collaborate and join force, right? Okay. So that being said, so let's start. Would that be all right?
Yes, a little bit
Okay.
of background, or do you want to pose specific questions?
Yes. Okay. All right. So I'll turn off my camera, okay, because I might be walking around right now. And okay, so I'll be okay asking some questions. So I guess first is GJ. Can you maybe describe a bit about what is your current like work? Okay, mostly, and the current focus. Okay, yeah.
So a little bit of background. I come from, same as Herman, from an electronic engineering background. My original area of specialization is telecommunications, information and communication systems. Worked on software radio back in the day. And then when Herman and I founded the media lab here at Stellenbosch, my focus shifted more to at that stage what was called the new media, social networking, new forms of broadcasting, content security, all of the signal processing that has to do with that, and a bit of a stronger focus on software engineering. And then, as Herman said, I left the university for about 5 years to pursue one of our inventions in industry and to help commercialize it. And I'm back in a newly formed position called the Research Chair in IoT. And it's a bit of a strategic attempt from the university to try to get better tech-related collaboration between various departments and faculties in the university. So the stuff I do, the stuff I like, is everything on the intersection of disciplines and environments. I really get excited by things that overlap in unusual ways. So in the university, that means I really like seeing where there's opportunity to take machine learning and robotics into agriculture, or into biomedical sciences, or into intelligent transport systems. But then also the other overlap that really energizes me is the one between academia and industry. And that's part of my mandate as well. How can we drive cross-disciplinary research that has a good opportunity to spin out and have impact in society or in industry as well? So the opportunities that I've been working on over the past few months and collaborations that I've been setting up, the one, as Herman mentioned, is in agri-tech. And I think there's a realization from the agri-sciences faculty here at Stellenbosch that the field of agri-sciences has shifted and shifted away from their old specialization in agricultural economics and plant pathology and things like that, and that it's moving into precision farming with technology-enabled precision farming. And there's a host of different collaboration opportunities there. So we're trying to see what expertise we have at engineering and computer science at the moment in autonomous vehicles, ground vehicles, air vehicles or drones, space vehicles, satellites, machine learning for processing very large data sets. So you're working in an environment there where you have decades of sensor data that's been recorded in the field or over satellite, but where we're trying to see whether there are new insights that can be pulled through from that using the latest advances in deep convolutional nets, for example. So there's a number of topics that we're pursuing there. When Herman started talking about spatial routing and route optimization, an industry project in agri-tech that I'm working on at the moment immediately came to mind, where we're working on semi-autonomous vehicles inside rows in fields, delivering chemicals to the crops. And part of that is just being able to monitor whether routes that are followed are actually satisfactory from an agricultural perspective. But the moment you've got something moving through space with intermittent or noisy geolocation data, it becomes a fairly challenging problem just to check whether all rows in a field have been covered. So there's some interesting work to do there as well. And then aside from agri-sciences, I'm doing a lot of work at the moment in biomedical IoT. Anything from one of the projects I'm involved in at the moment has to do with a very typical emerging world problem, which is that babies get born without the mothers knowing what the gestational age of the baby is when the baby was conceived. So there we're working on an IoT device that can be used in neonatal clinics to very quickly measure just the foot size of the newborn baby and indicate the gestational age of the baby, how long the baby was in the womb, so that the right care can be given, and a number of related biomedical IoT projects as well. And then I'm setting up collaboration again with one of my former colleagues, actually one of my old PhD students here at Electronic Engineering, again in intelligent transport systems, and seeing whether we, and when you look puzzled, Tinus Boysen, in intelligent transport system and intelligent energy management systems in public infrastructure. So scattered all over the place, but the stuff I'm trying to do is to see what dots can be connected and where I can identify good emerging technology in engineering and computer science and connect it to good and interesting problems in different domains at the university.
Okay, nice. Okay, all right. So I guess one question I have is in the fields you just mentioned, like agriculture, biomedical, what are some, I guess, major important problems that you have come across that sort of struck you as like an important challenge? Can you maybe share a bit on that? I mean, this may or may not relate to spatial routing, but I just like to know, like, what are some sort of these big challenging problem that you have came across?
So some interesting things. This has been an interesting year from a biomedical engineering perspective, because we've suddenly moved in an environment where people can't simply go to the doctor. You fall ill, and there's been a resistance to go to a clinic or go to a hospital or go to a doctor, because the risk of exposing yourself to disease becomes higher. So suddenly there's a dramatic increase in interest in remote medicine and the ability to monitor patient health from a distance. So I think one of the shifts we're going to see in wearable devices is away just from health and fitness to medical monitoring as well. So an interesting thing that also emerged this year is that even with health and fitness wearables, you can pick up signs of impending disease in a person. You can pick up things like heart rate variability and tempo of heart rate. If you can measure body temperature, fluctuations in body temperature, that could be very early indicators of disease. And some of the newer fitness devices also come with pulse oximeters that can measure the oxygen in the blood, and that, of course, is especially with COVID, is an early indication of very serious complications with disease like that. So one of the things I'm interested in looking at is firstly, a better improvement of the wearable devices we can manufacture to do remote monitoring of health. And I'm already, via an industry partnership, I've worked a little bit on a wearable for babies for early disease detection in babies in remote areas this year. And the other one that I have a student on tentatively for next year is in and this more on the broad IoT and data engineering side, being able to monitor or getting early warning of disease hotspots through aggregating data of wearables. So it's been something we picked up several years ago already, is that you can detect the hotspots of the spread of flu, for example, simply through Google through the Google Trends, the terms that people search for in certain areas. So the moment disease starts spreading, you see changes in behavior, even changes in movement, in how people use their mobile phones, for example. And now with the proliferation of wearable devices, it might be feasible to monitor and manage the spread of epidemics through quickly picking up small changes in patients' vital signs at an early stage. So we're interested in seeing what data we can acquire there, whether we can work with one of the local wearables companies and see whether we can pick up how disease is spreading through a society. I think that's going to be more relevant in the near future. Then on the societal impact work, one of the proposals we're working with there is to see whether we can apply blockchain as a mechanism for governance in public funds. So that's a proposal we have in for funding at the moment. So I'm working with a couple of colleagues there that have done some excellent work in the use of IoT devices in public infrastructure in schools to monitor energy and water usage, and just demonstrated that with very, very simple, cheap IoT interventions, you can cut down on the spending in public infrastructure quite dramatically. And we want to see whether we can take that a step further and use blockchain as a way of monitoring and managing the allocation and the spending of public funds, whether there are more transparent ways of seeing what happens with funds that get allocated to certain projects through that. And then on the agri-tech side, I think the other interesting challenge is just processing the mass of data that's been aggregated there. So the agri-IoT guys talk about these data cubes that they have, where over a long period of time, geospatial data was collected that could be a combination of satellite imagery, very sparse sensor data that ties into this geodata, denser sensor data. The temporal sampling of this data may vary greatly between the different types of data that's available. So you've got this multidimensional structure, almost this tensor of data that's available. And the question there is whether we can use advances in machine learning to better interpolate data over here. Can you take a data cube like this and fill in information between the sparse sensor readings by almost using a type of super resolution from the denser sensor readings that's available? And how can you use that to monitor potential pockets of disease in a geospatial landscape? How can you use this for prediction of potential crop health or crop disease in future? Can you do yield predictions using that? So marrying this very amorphous blob of data in a way where the different types of data fuse together in a sensible way and can be used as a coherent set of information to make predictions. So that just off the top of my head, I think the interesting research opportunities.
Okay, nice. Okay, thanks for sharing that. So I guess regarding some of the okay, so these topics, challenges, they are mainly now they came to you through I guess through your collaborations, collaborators, partners, right? And right now, I mean, how do you, I guess, decide or judge like which project to tackle on, and that's actually actually engage, like what are some of the key considerations that when you are, because obviously it looks like there are many different interesting research projects, right? But what are some of the key things you look at when you are deciding on?
So for me, and Herman will know this description because I like using it. For me, very important is the 3 boxes need to be ticked for a really excellent problem, and that's academic impact. So we're not here just to do engineering and to build something. So if we do research, we like to do it at the forefront or some other field. It might not be at the forefront of engineering, it might be at the forefront of agri-tech, but applying recent advances in engineering in that field, but it needs to have academic impact. The second one is societal impact. I like working on things that can make a difference to the world in a positive way. So not just things that will make money, but also things that can improve public health, can improve people's lives, can improve food security, things like that. So societal impact, and the other one is economic impact. I like working on projects where there's a potential to take this to industry and make a successful product or business, or take it into an existing business where they can make it grow and make it commercially viable as well. So if it ticks all of those 3 boxes, academic, societal, and economic, That's usually a good indicator. And then the other one, of course, is because these are cross-disciplinary topics and sometimes cross-academic and industry topics, it's critical to have excellent champions in the various domains that are working together. So I'd be very hesitant working on a biomedical topic, for example, if I don't have a collaborator in that field that's as enthusiastic about the opportunity as I am. And similarly, where we can tie industry interest to academic interest and get that open innovation going, that's also a good indicator for me.
Okay, nice. All right. So if using those criteria you just mentioned, okay, the first is the academic impact, the other is this, the socio-societal impact, and then economic impact. What projects or areas would rate the highest now in your mind? Maybe if you can share the top one or two. What are some in your mind?
Top of my mind at the moment, the agri-tech. Reason being is there's, as I mentioned, we have a strong championing of that field from the relevant faculty. There's a deep realization from the faculty that they need to move into this field and collaborate. And at the same time, at my home department at electronic engineering, there are some of my colleagues there that come to me and say, look, we've got these fantastic drones and robots and autonomous vehicles looking for application. People shouldn't go reinventing the wheel. Find ways where we can apply these. So that's a good sign. I'm doing a lot of industry work at the moment through a consultancy firm that I started earlier this year. And several of the projects we're working on there are agri-tech related. So that's where we're working on the crop spraying project, where we helping a large local agricultural firm improve the way they deliver chemicals to the plants, and there's potential spin-off research there as well. So I'm any type of project where my industry consultation ties up with potential academic opportunities is a good sign for me, because that means there's already industry interest in what's happening there as well. And then
great.
I
Go ahead.
I think the agricultural data sets as well. There's I think one of the most important emerging technologies that needs to find as wide application as possible is the recent advances in machine learning. Because over the past 5 months, I've just been playing catch up in what's been happening in machine learning over the past 2-3 years, because there's so much happening in that field in terms of the capacity of what you can do, and I think finding domains with interesting data sets and interesting problems. And again, the agri-tech seems to have that. They have a glut of data. They don't know what to do with it. And they need to find better ways of, in the first place, improving precision of architecture, get more food for a cheaper input cost, because that improves food security. But also something that's very relevant, and talking about ticking that societal box in agri-sciences in the developing world, is enabling emerging farmers to make better decisions. So in South Africa, a very important political theme and economical theme is how do we bring people into agriculture that were excluded during apartheid. And the more we can use technology to lower the barrier to entry for such emerging farmers, the greater their chance to be successful. And IoT, as agricultural IoT, as a decision-making sport, I think is very important.
Wow, nice. Okay. So, okay, thanks. I think that's a very good feedback and the answer. So, what in agri-tech right now? Okay, can you? I mean, you described it, I think the chemical, the fertilizer problem. Can you describe in more detail? I mean, what is the problem and the challenge? I mean, like, how would you describe what is the problem and challenge now, and what are they trying to solve?
So taking that industry problem as an example, there we're working with a company that has an existing technology that can just adjust the rate of spray of a chemical depending on the speed of the vehicle and depending on the characteristics of the orchard that they're servicing at the moment. And this is the thing that gets put onto a tractor and gets pulled by the tractor, and there's a person there driving it. And what's becoming more of the theme in agriculture now is the farmer has a dashboard on a computer somewhere and can get geospatial data of what's happening on the farm, control what should be delivered where to which crops, depending on various factors, and then monitoring that what's happening in the field actually corresponds to what's been designed from the agricultural perspective. And one of the problems that we need to solve sometime is the farmer wants to know that the tractor zigzagged through the fields at more or less the right rate, and that each lane has been covered accurately. And there's sometimes a disconnect between the geospatial data that we have available. We might have a satellite imagery of the farm. It might just be something that's been pulled off Google Maps or Google Earth. And how do we marry that with the movement that's actually happening in the field? And how can we detect whether a tractor has moved at the right speed, at the right places, and covered exactly the right area? So there's a route matching problem there that becomes fairly less trivial to solve.
Okay, I see. Let me see if I understand the problem correctly. So it's like you have some tractors on the ground that can move autonomously and deliver the chemicals, maybe the fertilizers, right, to different crops, and they need to go through certain routes, right, in order to have the correct coverage of the land. But they, I mean, due to various reasons, they could be, get sidetracked by the landscape. Maybe the wind or whatever. So their routes may not be as precise as originally planned. And upfront, although you can have satellite image, I mean, like really like a high level or GPS kind of information, but that it may not be precise enough, and you may still run into basically routes that are not as optimal or as efficient as it could have been. Is that a problem?
That's right. And also accidentally skipping a row. So you want to make sure that as you've moved around, every row in the field or in the orchard has been covered. So it should be possible to see, that movement there was a little bit further than it should have been. There's an indication that by accident or deliberately sometimes, because these vehicles at the moment have human operators, and they might literally cut corners to reduce the work that they're doing, and you want to be able to detect
I see. Okay. So there could also be human factors.
That's right.
I see. But I guess the farm owners would like to make sure everything is being covered up properly. Is that right?
That's right.
I see. All right. Okay.
And then,
all right. So
sort of related to that, and this is more a future research project. So I'm also working with a small local startup in agri-tech that's at the moment they developed a little autonomous robot. That sole purpose of that robot is to move around where laborers are in the field. And be available for them to put down baskets of fruit on it, and it takes the fruit back to the truck that's going to take it away. So they've just finished their measurements with their client, and they save 30% of labor time by not having the blueberry pickers move from the orchard to the truck. So a third of the time of the laborers would have been spent just walking around carrying little bowls of fruit. But this autonomous robot moves between the workers, and it's there when they need to put down the bucket that they picked. And the bigger question over there is, Isn't there a more general problem in not just agriculture, but maybe construction as well that can be solved in using autonomous vehicles like these? For example, imagine you had an autonomous conveyor belt. So you have a bunch of these little autonomous robots, and this is literally just a platform with 4 wheels that can move in either direction and turn around on a penny. But where you have a fleet of these little robots that can move around in loops from where things need to be picked up to where things need to be delivered, and that loop can adjust itself autonomously over time. So as workers move from one part of an orchard to another, or as construction workers move from one part of a building to another, this conveyor belt little row of robots can pick up where they need to be, optimize their route, and always be available when something needs to be put down, or when a worker needs a next brick or something like that. So I think there's a more general improvement that can be done to worker productivity, but that requires a much cleverer fleet of these robots that can do some clever route planning in their movement.
Okay, nice. All right, thanks. All right. So yeah, thanks, GJ. So Herman, would you like to feedback and comment after listening to what GJ described? Anything you feel in particular that would be interesting and fruitful to work on?
Oh, okay. So I guess my question is there like one area, so where is an area where we can have a minimum amount of effort and basically show that the spatial routing has, some measurable improvement or benefit or advantage that it gives to solving one of these problems? And I guess with the because we know one of the issues, well, except for the fact that we don't have a working implementation yet, but I guess one of the issues is also that measuring very fine distances in spatial routing is also a problem. So I guess having wearable devices where you're measuring locations on a single person's body might not be the best way to go about it. Yeah, so what I'm thinking is there something somewhere where we can deploy spatial routing and show, look, if we use spatial routing over here, look how easy it becomes to get all this information that you want, or to process the information, or to, I don't know, organize the information that is available.
Okay, so is that a question though?
Yes, it is a question.
Okay, all right. And are you just posing in general, or you're asking GJ?
No, I'm asking GJ. Yeah.
Okay.
Of all the projects he's involved in.
I'll probably need to put a little bit of thought into that. My hunch is it's going to be in using autonomous vehicles to improve worker efficiency, and to monitor the correctness of work of a laborer, because that's a common theme in both of these projects. You want to be able to monitor accurately whether something that should have moved in a certain area has moved in a certain area, and you want autonomous vehicles to be able to cleverly plan the routes that they move around to minimize wasted time or wasted effort by humans, so that humans can focus on what they do best, and the vehicles pick up the slack and are available when workers need them. So there might be something, but I'm not entirely sure yet.
Okay. All right, so that's definitely something worth exploring, right? Mm-hmm. Okay. All right. So yeah, any other feedback from her?
No, well, I mean, I've been working with Gert-Jan for many years, so I know he tends to be the more long-term vision type of guy. Well, I'm usually more short-term focused. What can we do? What's the implementation detail that we need to sort out?
Okay.
Yeah.
All right.
Okay. So I'm definitely think we can. Yeah. To me, I think the important part is going to be to define one or two topics where we say, okay, let's focus on this. Let's try and get something out that we can demonstrate the benefit that students will be excited about or will find interesting, and that we can start to build up some momentum so that people will say, oh, that's an interesting idea. Well, we want to be involved with that as well. Kind of a like an early win to show that the topic is feasible and that has benefit. That's basically what I'm looking for.
Okay, nice. All right. Okay. All right. So let me just share my feedback. Okay. So first of all, yeah, thanks GJ for sharing all these, I think, very insightful learnings and experiences. One thing about my background was, I started playing games and I was really interested in all these virtual world stuff. So the problem that you just described in terms of how to best position, I think maybe we can find some solutions in the path routing algorithms of AIs or NPC characters. Okay, because you might have heard of the games real-time strategy RTS games, right?
Mhm.
You might have, I don't know if you have played them like years ago. I think in RTS games they employ something similar when because when I'm trying to imagine what you're talking about on the field, with maybe the robots spreading the chemicals, or I actually picture, like in RTS games, you have all these actually robots, although they're virtuals, but they have to move from one place to another and according to certain rules, and maybe avoiding collisions to one another. Okay, so there actually has already been, I think, quite extensive works in this area regarding, although it's in the game, in the game, sort of the game AI field. But this is something I think that's interesting to look at, okay? Whether they may be applicable to design the potential routes, the best routes, right, for doing such things. And the second feedback is, I think what we are working on now, which is actually a distributed algorithm for spatial data collection, management, routing, okay? This will be of benefit in such scenario where you have maybe many devices that potentially are able to communicate with one another, okay? But because they're in the fields, okay, so it may be either too far, too latent, or just to reach and talk to a centralized command center, right? Or in your case, when you're talking about like GPS position, it could be inaccurate, right? So this is where I think a distributed algorithm will actually come into play, where if you can think of every like robot or vehicle has its own kind of independent thinking, but they can still collaborate with each other. They may be able to, first of all, get a more accurate picture of each other's positions. That's one. And secondly, they could plan out their routing much better, okay, and even faster than perhaps a centralized approach. Okay, because with centralized approach, that means you have to first collect the positions of everyone, plan out what's happening, send it out to them, execute, and then, and we're talking about latencies, and, it can be short or long, right? And it could be affected by other things like any kind of communication breaks between the centralized command center and the field robots, right? So I think this is something definitely related to what we are working on now. Okay, so I guess these are two feedbacks I can provide now of just hearing about what you said. A third feedback is I am also connected to one of the main organization in Taiwan that has pushed for organic farming. Okay, they have been doing this for 20 years, called Zixing Organic. In fact, my software company right now is doing an IT system to help them to, sort of automate the processing of their applications from farmers to apply for organic certificate. Okay, So, I mean, this is called Cixi Organic in Taiwan. They're one of the biggest and the oldest organization here. So, I mean, this is just in terms of agri-tech. I think there might be some projects and some other applications that may be also useful, you know, to collaborate with them when the situation arises. Okay, so
there's another interesting routing application as well that sort of flips it around. It's not always the machine that needs to be routed. One of the something that I saw a local company do, but where I think there's scope for more sophisticated research is the foot monitoring of plant disease. So if you have an orchard of apple trees, for example, one of the important jobs of the farmer, and this is usually the farmer himself that does this because it's a fairly sophisticated task, is walking around the trees in the orchard, trying to identify pockets of disease, trying to see whether there are leaves with some other pathogen on the leaf, and monitoring where this happens so that intervention can be given, whether it's chemical, whether a tree needs to be removed or something like this. And it's critical that it's done correctly because many of these diseases spread. Once they're in the orchard, they can infect the other trees as well. So what one of the local company does with their drone technology is they fly over orchards, for example, take imagery, and they try to identify where there are suspicious-looking foliage in the orchard. And then they recommend a route for the farmer to walk. So because obviously the farmer can't check each and every tree in the on the farm. He needs to sort of do a random walk through the farm and hope he spots something going wrong. But with the drone imagery, they can say you should at least be here and here and here, because there seems to be something going on in the near infrared spectrum that looks suspicious. And then they recommend a route for the farmer. And I think, especially if we combine this with these spatial cubes of data that's already available for the farms and other sensor technology, being able to help humans move through orchards or farms in a cleverer way, so that with a higher likelihood they can detect problems, might be interesting.
Okay, nice. One question is the imaging taken beforehand? Is the imaging taken beforehand, or is it like real time?
As I understand, it's taken beforehand. So the drone will do a coverage of the farm for a couple of days, and then it spits out the recommended route for the farmer to go and do his inspection, or just indicate where there could be problems.
Okay, all right. Okay, so yeah, Harman, so maybe you can feedback a bit about, is there anything you feel that that's workable? Yeah, from your perspective.
So if we think about the drone one, I mean, basically what you have is you analyze the data, and then from that you're going to try and figure out a route which it will work. So I think that one will, I think that, you know, I don't see how spatial routing would be beneficial there. But if you talk about so I was also thinking about if you have these a lot of these autonomous vehicles, and if you think about the consistency measurements that we did with, or that you did with VAST, and that Daniel Skoonwinkel did when he tried network coding with VAST, that maybe that's a way to improve the or at least get a handle on what the inaccuracies are in terms of the positions of all the drones and perhaps the guy picking the fruit. So I think that's an area where we can definitely look into. I think the other thing is that, and I think the benefit is you could start off something where you just have a virtual vineyard, right? And where you model the movement of the your drones or whatever, or your autonomous vehicles moving around, and then we can use that as a way of figuring, trying out whether the spatial routing will help in, you can model some inaccuracies of of the locations which is being reported and stuff like that. And then we can see, but okay, can we use that information to improve the location information of our various drones? And once we've shown that's work, then we could actually go, because I'm not sure if the drones are actually, they're running around in the vineyards at the moment, or the autonomous vehicles. I suspect not. But if the hardware then comes to the position, or is at the, we could deploy that, which we showed worked in the simulation. We can try and deploy that in a real vineyard and show, see here, yes, we do actually manage to get these things to follow the routes they're supposed to follow, and share the information that they're supposed to share. I think you'd probably need to compare that to having a mobile or a radio communication, just to, because I think the other aspect would be, if each robot doesn't have to communicate back to the farmhouse or to the base station or whatever, then you might also save some energy. Although probably with these autonomous vehicles, your energy is more going into your electrical motors than it's going into your communication. But anyway, so that's another, once we get to the practical implementation, that's also something we could consider looking into. So I do think there's a possibility there, with kind of minimum effort and independent of what's being developed in other projects, to actually set up a kind of a pilot study to see if there is some benefit of using spatial routing in a scenario such as that.
Mm-hmm.
Okay. Yeah. What do you think, TJ?
I think what's probably the logical next step is to advance that. If we say, well, it looks as if agriculture is a good area to focus in because it has this interesting set of problems and availability of data, I think the next step would probably be to pull in one of our colleagues at AgriSciences and bounce some ideas off them.
Yeah.
Okay. Yeah, that sounds good. That sounds good. Yeah. I would definitely agree. I mean, because they're the experts, right? And they probably know what are some of the more impactful questions, right, or problems that they're facing. And perhaps we might be able to discover, something that even, that could surprise us. Yeah. Okay. All right. Good. I think that's. Yeah. Okay. Go ahead.
What would also be useful is in a discussion like that. I think the kind of dots that we're trying to connect here is saying that there's a certain capability or capacity that we have available, the technological capacity. Where's the best place where this can be applied? How do I describe what our capacity is in spatial routing, so that one of my colleagues in AgriSciences can easily see, oh, this will be useful in this area.
But repeat that quickly.
So for you as a research group that's been working in spatial routing for a while now, what's a good way to describe what your capacity, what your cutting edge capability is?
Minecraft. No, I'm joking. So we do have so there is I believe Miguel Smith did a demonstration where he basically integrated spatial publish subscribe into Minecraft and basically showed that you could replace the server client architecture with a spatial pub sub, and you still had everyone moving around as they're supposed to be moving around, if I remember correctly. I guess the problem with that is you're basically just showing that things work as they're supposed to work, which is, yeah.
But important, but there's one important thing, which is it's without a centralized authority to collect and manage all the data.
That is, yeah.
Yes. So in this case, I think the main differentiator is, so we may be able to track positions and potentially even triangulate them more accurately than a centralized approach, where you have to go to some communication center or central command and then do everything there. Okay, because if they're moving, right, then sending back and forth, that would incur latency. So I think the core of what we're doing here, the key word is decentralized. Okay,
Mm.
and decentralized means that there's no single authority or no single point of failure that's needed, and we are still trying to come up with the same results, you know, and potentially, if you take latency into account, that could even mean better results. Or
Mm.
is that GJ? Is that what you're looking at, or I mean, would that satisfy what
I
you want to?
think that's very useful. And something else also, the topics that I described now are the ones that we looking at immediately or already working with industry or that came to us from agri-sciences. But there's a couple of more science fiction-y topics as well if we really want to do something ambitious. So one of, for example, one fascinating industry project that I'm not directly involved in, but that a company that I do some work for is involved in, is in programming bees. So they discovered a way in which they can hack the behavior of bee swarms through the way that the hives are constructed, and they discovered that certain manipulations in the hive foundation cause the bees to behave in different ways, and can be used to program them to pollinate plants in particular ways and be productive in different ways. And an interesting question is whether you can apply that to other groups of animals as well. So, for example, if is it possible to build little swarms of robots that can be where the sheep are grazing, and through their movement manipulate the movement of a herd of sheep, so that the farmer can place them, or so that they can be routed through a farm to optimize grazing efficiency, so that you don't need humans or herding animals to manipulate the herd. We know how to move robots around in the field so that we can move a herd from exactly one position to exactly where we need them, and things like that. What other opportunities are there to use IoT technology to affect the way that groups of animals behave? So like I said, that's a more science fiction question, but there might be some interesting questions to look at there.
Okay, all right,
So-
thanks, GJ. Herman?
So in terms of demonstrating what some of our capabilities are, I mean, I have a video which basically shows how we distribute the Minecraft environment over like 100 Raspberry Pis, and with the clients connected and being passed around. So that whole distributed calculation and things being kept up to date, that is something that we can, I mean, it's in a virtual environment, but I mean, some of the principles still apply. The routing there is not, it doesn't do spatial routing, but it does, which is basically where that other students' work came in, was as a start to show that we could use spatial pub/sub. And then what we want to move towards is basically replace the whole server client architecture with a spatial routing architecture while still keeping the distributed computation. But I think we do have, I mean, I have blinking lights in my office that I can show people with a video of, see, here it self-organizes and things are being passed around correctly. So I think that shows that we can do interesting stuff in a just distributed manner.
Okay, all right. So yeah, so thanks, babe. I think maybe we should wrap this up. Okay. So I think GJ, sorry about the background. I think there's some chasing. All right. So basically, I think GJ has shared with us a few topics, right? In agri-tech, in biomath that he's being involved and aware of, and points out that agri-tech might be one important area to look at. Okay, from multiple perspectives, and I think we have narrowed down to this particular problem of how do you allow autonomous pickers, vehicles, robots to work more effectively and maybe accurately. Okay, and this is something, I mean, the distributed spatial routing or the spatial data management work Herman has been working on can maybe apply, right? So I think this is something we can explore, okay, as a joint topic. And I think GJ made a very good comment that we should invite the agricultural experts, okay, in the discussion as well, because yeah, they may be able to identify some of the bigger challenge, the grand challenge problem that they're facing, and that potentially we can also help, right? Okay, so would that be all right? Maybe the next call will be with some of these experts.
I think that would be very useful. I think the person that we need to pull in is actually going away from the university now, but I think is still around. He's moving from agri-sciences research into venture capital. But he's the agri-sciences expert in agri-IoT, and he has a very nice broad understanding of the problem domains, but also good understanding of the underlying tech. So I'd really like to pull him into the discussion. I think following this conversation, something that I'm going to ponder about a little bit more is probably on the use of, I mentioned that smart conveyor belt, but maybe we should frame that a little bit differently and saying, what if we had a smart swarm of robots that is somewhere in a workplace to help humans do their job. And the job might be that every 5 minutes, a fruit picker needs to be serviced with a robot that comes to pick up the fruit basket. How can we make this swarm support a large group of humans working in a field or working on a construction site most effectively by being exactly at the right place at the right time when they need it, or something like that? Because I think this IoT supported and robot supported human labor is probably, no pun intended, the low hanging fruit.
All right, great. I think I was thinking about a term, swarm assisted. Well, swarm assisted. How do you call that? Deliveries or pickups. Okay. I think we can think of the term. Yeah. Okay. All right. So yeah, Herman, you want to say something?
Yeah, sorry, I have to run to. I have to say hi
Okay,
to the
same here.
external
Yeah.
moderators. So,
right.
so yeah, but
Okay.
I'll speak with Gertjan and set up a next meeting for us to discuss this and invite the other person from Agritech as well.
I
Okay.
think that would
All
be
right.
useful.
Great. All right. So thanks, CJ and Herman.
Thanks, gentlemen. This was fascinating.
All
Thank
right,
you.
thanks.
Bye.
So yeah, till next time. Yeah, thank you.